Okay, 7th graders, we're going to go through a lesson on scatter plots. Lesson 8.5. Yesterday we talked about functions and writing a function rule. We'll go through that again on Monday, so we'll cover that when everybody's here. But today is about scatter plots. Now, a scatter plot means that all the dots are not necessarily on a straight line, okay? It's a group of data points that may form a kind of a cluster of points. Look at the example on the reteaching page that I gave you. And at the top it shows Wimbledon wins and US Open wins. So these are players that have won both. Now take a look at the points right away. Is this a function? Is it a function? The Wimbledon wins and US Open wins?
No.
Is one a function of the other? No. No, look at, see if you can find two dots that are stacked up on top of each other.
I can.
Yeah. Yep. 3 and 4, right? Or 4, 3, and 4, 4. So, we're not talking about functions here that change for every time, but these are not functions. So what we say is that scatter plots can have correlations. Rather than being a function or a positive slope or negative slope, these might have a positive correlation or a negative correlation. All right? A correlation is a trend in the points. Okay? And it might have a positive correlation where the points kind of go up to the right in a slope or whatever, okay? Or a negative correlation where the plots kind of go down and to the right, okay? Now, what if they're all over the place? What if the points are just scattered? Then is there a correlation there? No, you would say that there is no correlation. There's no correlation between, in this subject, whatever is being plotted. Okay? So, that might be an answer to that question of, is there a correlation in this scatter plot? And you might say, no, there is no correlation. There's no trend that's shown. Okay? Let's take a look more closely at the example. It says, make a scatter plot. So they made a scatter plot. They plotted those points. There does not seem to be a trend in the data, it says at the bottom of that example. As the number of US Open wins increase, the number of Wimbledon wins does not seem to increase or decrease. So there's no correlation. Does that make sense? Let's make one together. Number 1. Make a US Open wins, French Open wins scatter plot. So using the data at the top of the page, plot those points. And we're going to use US Open. So I'll use mine up here and you use yours for US Open and French Open. So the ones on the side are going to be French Open. Now notice all of these are positive points, aren't they? All right, can you have a negative win? No, no. So these are all the positive points. We're only using quadrant what? Which quadrant number is that? 2. Remember? No. The quadrants go 1, 2, 3, 4. And we're only going to be plotting in quadrant 1. right? So only in this area. And the numbers are just going up by ones. So 2, 4, 6, 8, 10, 2, 4, 6, 8, 10. And for the points, so the first, Andre Agassi, plot the U.S. and French wins. What's that one, Dylan? Come on, follow along. I'm helping you to do this, okay? You should be doing this with me. We're going to do this together. Otherwise, I'll just assign it for homework. Okay? Andre Agassi is at where? What is the point given? Comparing U.S. Open and French Open wins.
1-0.
1-0. Does everybody see that?
Yeah.
1-0. Jamie Connors. Joey?
5-0.
Next, Chris Everett.
6-7.
6-7. So plot that point on number 1. We're plotting these on number 1, right here on your sheet, okay? Number 1. Everybody do this together. Do this with me. Steffi Graff.
5-5.
5-5. 5-5. Next, John McEnroe.
4-0.
4-0. Martina Navratilova.
4-2.
4-2. Pete Sampras.
He is 4-0.
4-0. Another 4-0. And Monica Seles.
2-3.
2-3. Does there appear to be a trend? Do the points seem to move in any direction as you move to the right? Which way do they seem to move? If you were to draw around these points, Joey?
They move to the right.
They seem to move up and to the right. What kind of correlation would that be?
Positive.
A positive correlation, right? Yep. Any questions on what we're doing? Do number 2 by yourself. Plot the points for Wimbledon wins. Make sure you use the correct columns. Wimbledon wins versus Australian Open wins. And then tell whether it is a positive correlation or a negative correlation. Yes?
For number 1, does it matter that there's 2 4-0s or not?
No. No. So, what did we learn about scatter plots? What is a scatter plot?
Scatterplot.
Kira?
It's when the points, like on the graph, are just kind of spread out everywhere.
Right. Yep, they're just scattered about. They're not on a certain line, right? So this is not a linear function. Look at these 2 points. They're stacked on top of each other. That shows that this is not a what? Class? Not a what? Not a what?
Function.
A function. This is not a function. Get used to those terms. I want you to learn those terms and learn how to use them. This is not a function because look at these 2 points are right on top of each other. Okay? So this is, we're not graphing a linear function, we're graphing what's called a what? A scatter plot. Yep. And we're looking for a what, class?
Correlation.
A correlation. A positive correlation would go up to the right. A negative correlation goes down and right. What if there is no correlation? What if they're just scattered all over? Then there's no correlation. Right. Any questions on this? This lesson is mainly introducing you to these terms. Mainly introducing you to positive, negative correlation, no correlation, and what a scatter plot is. Okay?